Today we are going to see where the derivative of the exponential function is coming from. Okay. So if we have for f of x as a exponential function, then we write that in the derivative mode, which is the limit when h tends to be 0 of this. We know that here we can factorize a to x, a elevated to x, like we have here, and put it back. This term is not having any h anywhere, only this one, right? So, and the limit is based on h. So, because that, we can move this outside, right? Now, we don't know exactly what this will be if we don't know what is the term a, right? We may need a calculator, but we need the value of a. So for that, we have to use a mathematical trick. Is this: if we rewrite a as a e elevated to logarithm of a, then we can have this part like that, right? So the exponent h will be the exponent of everything, but by the exponent rule we will have this multiplying as we have it here. Okay? But we know from the previous video, the squeezing theorem of the limits, that this limit basically is 1. Okay? So how can we leverage this part? Well, we have to do a substitution here. We have to substitute t will be equal to logarithm a times h, right? We know that t will approach 0 as h approaches 0. And by the way, here we have that this will be t over logarithm of a is equal to h, right? So if we move the logarithms to the other side, we will have this. Okay. So how we will have now the limit? This is how it would look like. Basically, we will substitute this part by t, right? We will have here this new term because the substitution that we have earlier, and of course this part here is dividing t, but we can multiply this by the denominator and we will have it like that form. But this is a constant. This is a number that is not attached to the limit, right? So we can move this at front of the limit and have only the limit, the part of the limit that is with a connection with t in this case, because we replaced the h by t, right? We have this substitution. So, and because this is basically, this is 1, we will have that the logarithm of a times 1 is logarithm of a. So coming back to the derivative, we have this, right? Remember that we have that we moved this a exponent x outside of the limit, but this limit we didn't know what it is, but then we do the substitution, and now we know that the logarithm of 8 that ax will be basically the results for the derivative, or in other words, we can have basically this form directly. This is a shortcut for the derivative. And by the way, if we have f of x e to the x, in this case a will be e, right? So the logarithm of a times a to the x, this is 1, right? So we will have that this is, I'm sorry, f prime of d will be f to the x. Okay, Thank you.